blocks worth of material. 2.5 blocks worth of the town site lost. And what that equates to, here's a picture of Midtown, is basically all those buildings fell into the river this year, which is a pretty sad state of affairs. There was a Qikiqtaruk component. I guess the original settlement in Dai was a Qikiqtaruk village, about which we know relatively little. The whole Chilkoot Trail was established by the Chilkoot Qikiqtaruk and managed until the Stampeders basically commandeered it in 1897. This disruption of the stampede and this pioneering event was incredibly detrimental to their traditional lifeways, territorial holdings, and so on. And one of the interesting things about the NHL is that we just have a kind of a bare minimum understanding of where the Qikiqtaruk village was. And the Qikiqtaruk village was the anchor point really for the site. I think the raison d'etre was a canoe harbor for the Qikiqtaruk, and then the Western Euro-American development kind of developed on the outskirts. And really the focus was the Qikiqtaruk village. We don't exactly know where it was located. You can see the image of the Qikiqtaruk folks here. And then here's a Euro-American structure pre-gold rush, and you see some structures behind it. And here is the area for that pre-gold rush building. It's already fallen into the river, and the Qikiqtaruk village is somewhere just behind it. Erosion in the park unit is really watershed wide, and we're experiencing really dramatic loss. Also, I think the second largest and probably most fruitful site in the Chilkoot watershed. Here's the Dai town site, and here's Sheep Camp. I think of it as like the sister city to Dai. It would take you multiple days to get up here. You're about 13 miles away from the tidewater. And it is probably a richer landscape for archaeology. This park is a one-of-a-kind resource capturing the material culture from the 1890s. You can see here's an extensive development. I mean, it's really a huge site, but on the surface, just walking around, it's really replete with objects. Basically, people probably didn't want to carry over this traumatic Chilkoot Pass, which I don't blame them. And then in August 13th of this past year, we experienced major flooding. And this is what I mean, like major flooding and mass movements that impacted the historic site and also NPS campground infrastructure. It was pretty dramatic. Also, Dai Sheep Camp, we see erosional problems happening at Finnegan's Point, also kind of this a waypoint along your journey up the Taya watershed for the Qikiqtaruk, and then later for the Stampeders. And yeah, we've had to relocate a trail this last year and the year before. And I guess one interesting find to kind of nerd out about was this 1897-98 telephone line that we saw extending. And you can't really see it in this image of the Pacific Hotel in Dai, but this sign says Sunset Telephone Company. And it just blows my mind that, this is a really young invention in 1897. And then here it is kind of on the Western frontier, kind of, I guess the edge of America. And you see this brand new technology. I think of it as like, I don't know, an Apple store and maybe Skagway today or something. We also see erosion happening at a nearby site. I think of it as North Dai. It's called the Kinney Bridge Complex. And it's been excavated by my predecessor in 2015, but you can see the Kinney Bridge, North Dai, you would, Stampeders would leave and can you try to charge a toll, but people didn't really like that very much. And then you would begin your journey up the Chilkoot Trail. And it was like its own kind of neighborhood, and there was a lot of infrastructure. Here's his map from the 2015 excavation. You can see the footer of the Kinney Bridge, again, right here. And then a series of structures that he managed to put some excavation units in, but by no means comprehensive. And we revisited it this year. Here's the 2015 bank in orange. And then here's our 2021 bank in red, and all of his excavation units, well, almost all, had eroded into the river. Also across the river from the Kinney Bridge site, the Park Service has really last minute removed a gold rush period cabin at the McDermott property. So I wanted to kind of build on what Patrick had mentioned earlier about this multi-factor erosion, that, you know, it's not as simple as, wow, things are warming up here and now we're losing our sites, that there is those signatures, but it's more of a complicated story. And I'm curious that, you know, looking at all these papers, if everyone isn't identifying these complexities, and if some of these complexities are common. And here, I'll explain more. So we definitely see these bigger trends. I think this is the macro scale climate change of increased snow and rain, warmer temperatures. And we don't have great precipitation data, but we do have great stream discharge data. So we catch the precip signal as it leaves the river system. Here's Finnegan's Point, where I was talking about. Here's historic Dai and the Choco trails further up here. And here are the two stream gauging stations in yellow. One's on West Creek, and then the other one's right at the town site. And basically, here's a summary of the climate signal to me, and I'll make this as simple as possible. Here's 1970 to 1977, and here's total discharge for the year. So all the water leaving the system, boop, and then here it is in the 2000s. And one thing that really helps me sort of anchor when I see graphs like this is give me some relative line. And in the 70s, you can see total discharge was less than what you see here today. And also, looking at this, you can see discharge is perhaps increasing as we move closer to now. And we'll revisit that here in a moment. Another thing that's happening isn't just a total increase in discharge, it's the time that it's arriving, a real periodicity in climate change, where the blue line is basically discharge in the 2000s, the black line is the 70s. And what we're seeing is an earlier spring melt pulse. Not only are we seeing more water, but we're seeing it earlier in the season. And I highlighted the difference in yellow there. We're also seeing midwinter melts. Definitely saw it this winter, which has impacts on all of our cut bank vulnerable resources in the park. I highlighted the midwinter melt here. Again, 2000s, the lower line is total discharge in the 70s. Another thing we're seeing, and we'll perhaps see more of, are glacial lake outburst floods, or GLOFs. GLOFs is not a Park Service acronym. This is something used by the geoscience community. And basically what's happening is our glaciers are receding, meltwater is pooling up behind moraines, and poof, they release in dramatic events, which happened in 2002. And here's the MPS Dai campground covered in water. That campground is right here, right next to the historic town site in the cut bank, where we're seeing the most erosion. And then, just while on the topic of glaciers, here is just some evidence of climate change from repeat photography of our glaciers. And if you look in the left of the image, you can see a major reduction in glacial mass. And if you look to the right in the distance, you can see the glaciers retreating up the valley. And then one of the cooler aspects, in my opinion, of the erosion factors is kind of a positive, where the gold rush had major impacts on the canopy cover, and deforestation was rife, where you needed construction material, heating material, steam power to power the lifts at the scales. And then there was more logging in the 40s and 50s with the Hosford mill near Finnegan's Point in Dai. And what's happened since is a real recovery of the watershed. And what that means for erosion is it changes the river morphology and discharge total, where without ground cover, a lot of stuff hits the water or hits the river system. The river anastomoses. It can't carry all of that large load and kind of distributes its energy in multiple branches. And you can see the 1894 image, and then here's a Google Earth image of the watershed. And Dai is at the foot of that image. And you can see the stream is consolidating and then basically consolidating its power. Here's a nice repeat photography image from August of 1897 and August of 2013. I don't see any difference. I'm just kidding. That's pretty dramatic. Forest recovery and channelization. Just another view looking at Dai 1897. Here it is in 2013. A lot of forest cover change. Another factor, kind of the last factor, is human modifications. And this is especially pronounced at Dai. And if you'll notice the Alaska DOT levee, which is actually the entrance for the Chilkoot Trail when you want to hike it, or maybe some of you have, you're walking across an unnatural levee. And what that has done, I just put it in LiDAR, so it's really pronounced. Here's the levee in red. It's deflected the current that used to be flowing through that part of the channel. That's a relic channel, and it would distribute some of the energy coming through the Taya next to the cut bank. So effectively, all that energy is pushed right at the town site. So it's kind of begging the question: is there are a number of factors involved? Is erosion accelerating, or it's definitely, it doesn't seem to be decreasing? But one important thing to notice is that the cut bank has been part of Dai since Dai was Dai. That, I think, again, this is the raison d'etre for the site, that it was a nice canoe harbor. The main channel used to be over here, and it was a place of relatively quiet water. 1898, here it is in 1920s, and you can see gold rush material falling off. And this is before the levee and things were constructed. But here's the sequence. If you notice, here's 1950, let's say, 1960, 70, 80, 2000. And then it's pretty stable until 2017, and we lose a lot. And then here's what we lost this year in green. A quick, I think I like the way Patrick said, redneck GIS. Here's my redneck GIS version of this, where these are decades, and then there was this year. So decade, 20 years of stability, decade, and then all this year. And basically, for what it's worth, that's 66 feet a year of erosional loss. This year, we've lost 125 feet. That's a lot. That's more than we lost in 20 years previously. So what we're doing to address this problem, and it's kind of a reflection moment where, looking at the park, what have we done? And I try to think of nice ways to put it, but I think it's pretty acceptable to say that the approaches have been ad hoc and reactionary by and large to address erosion issues in the Chilkoot Trail corridor. And I also acknowledge that maybe environmental impacts were less severe, that things are becoming more pronounced and more apparent. It started with a move of the Dai Cemetery, a mixed Euro-American Tlingit cemetery in '78. That was pretty early. Some of the first archaeology surveys didn't occur till the 80s, 81 to 84. Some emergency work along the cut bank to move a privy, cabin moves, a survey along near the cabin, a hearth excavation in 2005. And then I think we've started engaging with long-term planning, beginning with Andy Higgs, who I saw was attending the conference and hopefully is listening, and like a real proactive approach to saying, hey, we're losing a lot of these resources. Let's get the infrastructure and out of the way and learn as much as possible before we lose it. My predecessor, Sean Jones, also worked at Kinney Bridge. He started the ice patch archaeology work here at Klondike Gold Rush, Finnegan Trail reroute, and then now our Dai cut bank work, where we're trying to do a large scale survey and data recovery. And trying to articulate this through a programmatic agreement with our tribal partners, the SHPO, DNR, to address not just Dai loss, but this watershed-wide erosion phenomenon. In the little bit of time I have left, I'll show you some preliminary results and kind of what's at stake. And yes, we always have this much fun, metal detecting and GPS. There's our inset map. We're at the Dike cut bank. This is what we lost. And then here are all our hits. And the red are surface metal finds. And here we've just zoomed in. And you'll notice there are a lot of hotspots. And what's amazing working here, I've worked all over the lower 48 and then also in other places around the world. And I've never had the resource of these historic photos. It's really, I think, the Klondike advantage or something. There's the false front. That resource concentration next to it must be the Astoria Dye Trading Company, literally the building in the image. And these concentrations are more than likely the restaurant that was right there during the gold rush. What that also means is the stuff in the background has fallen away. We didn't catch it. A total loss. Shovel testing through this zone also revealed an interesting phenomenon, just kind of like you can't just start digging and expect to find something in this historic zone, even though it's in the town site grid, that there's what we lost. And by and large, what we lost, we had already checked some of it, and there wasn't anything in the metal detection or in shovel tests. And there was real impacts from the homestead agricultural activities afterwards. And here's where the river went. I have about a minute left. And I just wanted to capture that, we're using this moment, this kind of long range planning to reevaluate our research goals to include not just, the basic research goals stated in our general management plans, but what do we want those outcomes to look like? And how do we enhance our partnerships? And one of the easy things to do is take some recommendations from our park ethnographic overview and assessment, focus on native history and cultural heritage, and protect sacred cultural landscapes, like potentially a native cemetery still left in the native village area. And then it's forcing us to prioritize zones because we can't address all these things on the cut bank or Kinneyville or Sheep Camp. And we have to kind of pick and choose the zones that will be, I guess, most informative towards our goals, like diversifying the gold rush story to include different looks at gender, ethnicity, and age of the participants in the gold rush. And also, really apropos for this session, human environment insights and connections and lessons that we could share with park visitors. Summary, erosion is happening throughout the watershed and especially at Dye. And the factors affecting erosion are complex, and we're taking a watershed-wide approach and trying to use it as a good thing to sort of enhance and move the park forward through this kind of making lemonade out of lemons. So, thank you for your time. I think I got to stop.
You're good. Thank you so much. And maybe Jonathan, you can monitor the chat and respond to questions if there are any. And I'm gonna hand it over to Leslie McCartney, who is going to be presenting next, observing the effects of climate change in 2 of Alaska's national parks. And we can see your screen. Thanks, Leslie. Welcome. If you're talking, you're muted.
There we go. Thank you very much. I hope everyone can see my screen.
It looks great.
Great. Well, thank you very much. And thank you everyone for being here today. So I'm using 2 computers, so I hope I use the right mouse when times come. So just be patient with me for a moment. There we go. So I'm going to talk today about observing change in 2 of Alaska's national parks. This project contains oral history interviews with longtime residents of Skagway, talking about their observations of environmental change in and around the Klondike Gold Rush National Historic Park, and with the National Park Service employees and residents of Nome discussing environmental change in and around the Bering Land Bridge National Preserve. The interviews capture the effects of change on cultural and natural resources in these 2 coastal park areas, and also speaks to the effects on human connections to these resources. It allows audiences to gain firsthand understanding of a changing environment and provides the opportunity to draw comparisons between 2 distinct regions in Alaska. I will say that support for this project was provided by the National Park Service. The Skagway interviews were conducted in 2018 by my colleague Karen Brewster, and I completed the Nome interviews in 2019 and 2020. Both of these parks border on water. You can see the Klondike Gold Rush down here, of course, and the Bering Land Bridge up there, which I'm going to refer to sometimes as Bella. So the Klondike Gold Rush National Park is on the Chilkoot Inlet, and the Bering Land Bridge National Preserve is on the Bering Sea and Kotzebue Sound. So located in the southeastern Alaska almost rainforest, the Klondike Gold Rush commemorates, of course, the Klondike Gold Rush of the late 1890s. Established in 1976, the park is almost 13,000 acres in size and includes Skagway, and as we just heard, the town of Dyea. The park is known as a biodiversity hotspot. The Chilkoot Pass is a good example of the varied ecozones and the biodiversity found in the park. The trail begins with the intertidal and coastal forest at sea level and then climbs to a higher alpine near the summit of Chilkoot Trail, over 3,500 feet. And then it changes to boreal forest towards Lake Bennett, which is just over 600 feet above sea level. In contrast, the Bering Land Bridge National Preserve, or Bella, is located on the northern side of the Seward Peninsula. It's a remnant of Beringia, and the land bridge that once connected Asia and North America, most of which is now beneath the waters of the Chukchi and Bering Seas. Established in 1978, the park is just over 2.5 million acres in size. Most of the land is in the preserve is tundra, underlain by permafrost. So unlike the Klondike Gold Rush, there are no roads into Bella. Access to the preserve is by bush planes or boats during the summer months and ski planes and snowmobiles and dog sled in the wintertime. So we're going to talk first about what the interviews revealed in the Klondike Gold Rush Historic National Park. Many, many changes were discussed, and we've just heard quite a few of them from Mr. Flood, so thank you for that. Many changes were discussed in these interviews, and I cannot cover all of them in this presentation, so I've selected 4 that were mentioned the most in the interviews, and I'm going to use some quotes to illustrate what was discussed. So the first, of course, was temperature and weather. First and foremost, people talked about the changes in the weather. Everyone said the winters were not as cold and severe as they used to be, and they bring less snow. Many people framed this in the following way. Many people said that when they were young, they used to skate on the rivers and ponds or on the rivers as they'd freeze over. Today, it's not cold enough for them to freeze. John McDermott said, "We are getting a fair amount less snow than we have before. We get breaks and warmer spells to melt that snow, or it turns to rain. Years ago, we had huge drifts of snow. We don't get that anymore. Back in the early days, I had a tractor. I'd spend all day digging it up with my bucket and go dumping it so I could get out onto the road. The next day, it would be all full of snow, just like it had been the previous day, and I'd spend another whole day doing it. But now the winters come by, and I've got a snow thrower on the front of my grade blade on the back, and I might only need it once or twice a year, maybe 3. Just like you heard in the previous talk, it's the receding glaciers that people are really talking about. Several residents spoke about the melting of the local glaciers. Jeff Brady, who's lived there for over 40 years now, said that the change in the ice field in the 40 years he had seen is absolutely amazing. And you can see that from the last presentation, actually, from some of the pictures too, although it was longer than 40 years. He said that after the summer of 2018, I quote, "Look at Mount Harding. It's now more exposed up there than it's ever been this summer. And if you fly over the ice field, it's just amazing what you see. What has come back and retreated, Mendenhall especially, and Eagle Glacier," end quote. Several residents spoke of how parts of the glaciers are breaking off. Joanne and Andrew Verley said, "The first thing we need to talk about is how fast our glaciers are melting away here in Skagway. We're just in tears some days when we see the big chunks of ice falling off our glacier, because it's amazing how fast the glacier is receding on Saddle Mountain or on Mount Harding. And also the glaciers like Denver Glacier and Lawton Glacier, You know, maybe since the 1970s, how far they've receded. It's quite a bit. And the speed at which they're receding. It's a big change from year to year. End quote. The next was people talking about birds. Many residents said they're seeing less of some birds and seeing new arrivals. Longtime Skagway resident Betsy Albrecher said that when she was growing up in Skagway in the late 1940s and 1950s, at the city dump, she would see seagulls and maybe a raven or two, but never crows. Crows were not seen in Skagway, but started to appear, according to Betsy, when the cruise ships started to come in regularly. Food being thrown overboard made a great food source for the crows. Joanne said that the crows follow the tourists. She says these crows come up here, eat all the drop popcorn, the tourist food, and there's thousands of tourists here every day, and they drop popcorn and candy and stuff. And so the birds have all this free food. They start to flock up and then go south at about October. And then they'll come back in the spring. And I tell you, the crows go south and they recruit more crows. They say, you want to have free food all summer? Come to Skagway, end quote. So we get more and more crows every year, she says. And the reason, she says, she continues to say, the reason I say recruit is because I know that there's more. I know they bring more crows up here, and we see more crows in Skagway that have metal or plastic bands on their legs. So there's a lot of crows. The crows do, however, leave the winter, and Dorothy and Jeff Bradley even said they eventually leave and the valley becomes peaceful again, but they will be back. Another new arrival people have noticed is the Eurasian collared dove, or ring-necked dove, a species native to Europe and Asia, and it's now been introduced to North America. Their population growth and expanding area has been prolific. As Betsy Albrecher said, they have invaded successfully. Unlike the crows, they remain in town year-round. Others report seeing red-winged blackbirds for the past 9, 10, 12 years, and the magpies and starlings, which they never saw in Skagway, are beginning to appear. People talked about pests. Now, gardeners are great people to talk to about plants, soils, and pests. Woolly bear caterpillars are now, as Betsy Albrecher said, they're huge and they're all over the trees in town. And the pests are not just above the ground, there's also new ones being found in the soil. Dorothy Brady said, we have what we call these night crawlers. They're these huge worms, and I don't know where they come from, but they are wrecking the yard. They dig deep and they hibernate, but they're as big as round as your little finger and probably 8 inches long sometimes. Lynn Cameron, another gardener, said, last year we had an invasion on the delphiniums of an aphid from Florida. I looked it up because it was the weirdest aphid I'd ever seen. We've always had aphids, but these ones were green. So I'm going to switch now to changes that were noticed in the Bering Land Bridge National Preserve in Bella. Again, temperature and weather were the two most mentioned. Everyone interviewed agreed that winter is coming later, and when it does, it is shorter because spring is coming earlier. This has implications for human subsistence activities. Longtime National Park Service employee and Nome resident Ken Atkinson said, warming up earlier and freezing later makes travel across country increasingly risky, both on land and on sea ice. People are having a hard time crabbing. It's not safe out there. Streams are not freezing or the ice is not as thick. It's dangerous. But the most noticeable change is the warming that's happening in the northern Bering Sea itself. These pictures are from a report from NOAA from 2019, and it shows the warming of the surface of the Bering Sea from 2010 to 2019. UAF Marine Advisory Agent Nome Gay Sheffield explained to us the rapid and shrinking changes that are also occurring at the bottom of the northern Bering Sea. Historically, when ice forms on the sea, it does two things. It locks up the fresh water and a salty brine is created below it. Salt water can be colder than freezing, but it's still liquid, heavy, and dense, and it goes to the bottom of the ocean very, very fast. Because the northern area of the sea ice is colder than the southern Bering Sea, there's like this invisible barrier between the two. NOAA has now found that the temperatures are very warm throughout the sea with no barriers between the north and south. There's still pockets of cold water, but nothing to hold back the warmer water fish, so they're coming into the region. So warmer water entices warm water fish such as cod and pollock, and now they're being found in abundance in the northern Bering and Chukchi Sea, which as much as 5,000% more than in previous years. This has a huge impact on the fishing industry and the migration of animals through the area, and far too complex to discuss in this presentation, but you get the idea. With regard to weather conditions, known residents Roy Ashenfelter said that they used to have lots of snowstorms in the 1970s and 80s, but the storms now are not as severe. Remembering how much snow Nome used to get, longtime Nome resident Charlie Lean remembered that when he was a young boy, almost a two-story houses that were on the first street were almost buried in a snowdrift on the seaward side. As a child, he remembers easily walking on the roof of one-story houses. The snow has not been that deep in years, he said. The loss of sea and river ice. Everything's connected. I just spoke of the warming of the Bering and Chukchi seas. Almost everyone interviewed said that it didn't freeze up as early as it used to, so the subsistence window on the ice is now shortened. Fellow Superintendent Jeanette Kolsch said, it is the time where they do a lot of subsistence activities. They do a lot of hunting and fishing during that time because the whole preserve is accessible. And that season is getting shorter. Rivers and lakes that they used to use aren't freezing as solid. So rivers and lakes where they used to go ice fishing at certain times of the year is just no longer accessible. And when it's not accessible by boat either, because you're in that weird time when the ice isn't hard enough and there's not enough snowfall and there's not enough ice for access. So it shortens the hunting seasons that also change because of access. The loss of ice is also causing more erosion and damage to the coast. As we get storm surges, the ice acts as a protective barrier to the coast. And when it doesn't exist for spring and fall and other winter storms, it really increases erosion. And it really makes communities worried because these villages are on the coast too. And protections that they used to have from the ice just aren't there, or they're just not there long enough, or the ice just isn't thick enough for them to be protected. And we've seen in quite a few presentations today about the erosion near the coast and how it happens to villages. The next is the loss of permafrost that was really discussed. Dave Swanson, a terrestrial ecologist with NPS, spoke about how the lakes in Bella are suddenly draining due to the thawing permafrost below them. This has always happened naturally, but it's now occurring at an unprecedented rate over the past few years, which have been the warmest on record. There's been lots of snow in the past few years, so the lakes were brimful of water, and then the permafrost under the lakes is thawing, the water finds its way out, and the flowing water enhances the thaw of the permafrost. This creates a perfect storm for the lakes to drain. In 2018, he said 3 lakes in the northern area of Bella were lost completely. They were large lakes, about a mile in diameter, and there were several smaller lakes lost as well. And in 2019, in the same area, another lake 1 mile across and another at least half a mile across, plus several smaller lakes also drained. In this part of the park, since the mid-2000s, half of the big lakes are gone, and so are many of the smaller ones. These lakes are used by migratory birds for nesting areas and food sources, and now they are disappearing. Roy Ashenfelter also discussed permafrost loss, noting that the land is not frozen as long or as intently, or is entirely missing now in some areas. There's slumping along the riverbanks. The rivers are now, have larger sandbars in them. And it makes it more dangerous for navigating the rivers. The next change noted was the beavers. There's been a dramatic increase in the beaver population and activity in the area over the last few decades. Charlie Lean said that in 1947, you could trap 2 beaver per year. Today, it's completely unlimited. And the beavers are creating major changes in the landscape by creating new ponds and watercourses, but their dams are also creating wintering ponds for the choho salmon and not allowing other fish to move upstream to spawn. So they're seeing a decrease in those species. So the changes observed and discussed in this presentation today are only a thumbnail of those that were mentioned in the interviews, and you can access these all online. The importance of this project and collection is that it highlights changes that are not only affecting the natural environment in these two parks in Alaska, but how they affect human activities and subsistence activities. Perhaps 75 years, in 50 or 75 years, these observations, along with other scientific data, will help create a more longitudinal picture of the changes that did and are occurring in these two national parks in Alaska. So I hope you'll access the Observing Climate Change in Alaska National Parks Project Jukebox to learn more about the issues that are raised in the interviews. And I want to thank you very much for your attention.
Leslie, that was great. Thank you so much, and perfect timing. We have a couple minutes for questions if anyone has any for Leslie.
Are we also doing Q&A at the end?
We can if there's time, and certainly over the breaks as well. It looks like Katelyn has a question. Go ahead and come off mute, Katelyn.
So sorry, it was a clapping emoji.
Oh, okay, good. Yeah, sorry, I
similar.
misinterpreted. Good. Okay, great. And folks are welcome to put their questions in the chat as well. Leslie, you can see the chat. And so if any questions come up, you can respond to them there. And we'll have time over the next break at 1:40 as well as at the end of the session. So thank you so much. And next, I'd like to introduce Kelsey. I'm going to mispronounce your name. You'll have to forgive me. Pennanen?
Hi, yes, Kelsey Pennanen.
Okay, thank you. Welcome. And Kelsey is going to be talking about digitizing and documenting change of ice patch landscapes in southern Yukon. We can see your screen.
Perfect. Awesome. Thank you so much for the introduction. Yes, hi, my name is Kelsey Pennanen. I'm a PhD candidate in the Department of Anthropology and Archaeology at the University of Calgary. So that's where I'm joining you from today, also known as Mohkinstsis, and Calgary is located in the traditional territories of the people of the Treaty 7 region, including the Blackfoot Confederacy, the Tsuut'ina First Nation, and the Stoney Nakoda First Nations. Want to give a land acknowledgement of where I am joining you from today in the spirit of reconciliation, but that's not where we're going to be talking about today. I'll situate us a little bit here. So, as of course, you know, this is the Alaska Anthropology Association, but today I'm going to be talking about the area, you know, from your friendly Canadian neighbors just to the east, specifically in the Yukon territory. And within the Yukon territory, I will be discussing this region in the southwest located here. It's colloquially known as the Southern Lakes region of the Yukon territory. And within this project, we've collaborated with 3 self-governing First Nations who have overlapping traditional territory within the region. And that includes the Carcross-Tagish First Nation, Klondike First Nation, and Champagne and Asiatic First Nations. Their input and experiences at these places are the backbone of this project, and the stories and histories embedded are what we're working to record and share with this project. And of course, I want to shout out the Yukon government for their years of work on the Ice Patch Project, their tireless efforts doing recovery and reconnaissance at all of these sites, working to navigate these collaborations and ensuring that these projects go forward and have engagement from various parties at all levels. So I really want to make mention of the Yukon government and all the hard work they've been doing and supporting this project as well every step of the way. So to get a little bit into this research, this story, as we've heard a lot about today, is really about a storied landscape inhabited for hundreds of generations by the indigenous groups local to the area. What's pictured here is one of my favorite stories. This is from Emerald Lake, and it's where the Northern Lights come to sleep for the summer. And for those of you that have been lucky enough to witness the spectacularity that is the Northern Lights, you can begin to understand this comparison and just how amazing and vast and really immense this landscape is. So Southern Yukon, similarly to Alaska, has some areas that are composed of towering mountains that are overlooking fish-stocked lakes, It looks remote and desolate, but as we know, as anthropologists, archaeologists, and people landscape, that upon closer inspection, it is full of evidence of human life and activities, and even what we perceive as the most remote corners of this world can tell us a story of perseverance and ingenuity. One feature that's pretty neat and unique in this region is in the high altitudes, some areas actually allow for snow accumulation to take place. So the vastness of these mountainous regions can be hard to fathom, and even the writings of amazing such as Robert Service really fail to capture it. These places have even once been described as unpeopled, but we've been demonstrating through archaeology and even this aerial exploration project that I'm going to discuss today, just how false that narrative is, that people have been surviving and imprinting history through relationships on this landscape for years and years and years. And we can see this evidence throughout the landscape. And not only is this landscape vast, peopled, storied, it's also a landscape of change. So as I'm sure a lot of you have experienced, and as we've been talking about throughout this conference, and particularly this session, climate change is having an impact on these landscapes, and ice levels and the amount of accumulation at ice patches throughout the years has been fluctuating, reaching some of the lowest levels experienced in the last 6,000 years, as evidenced from some of the recoveries that have been made at these ice patches. So typically the snow tends to accumulate on these high altitude areas on leeward and typically north facing slopes due to less sun exposure. And usually there's some melting experience, but not too much. In the last few decades, it has been at an unprecedented rate and has resulted in some pretty unbelievable finds and recoveries being made. So as these landscapes are melting and experiencing rapid change, this example is from the Gladstone ice patch. We can see the size that the ice had once accumulated to, and then the actual size now in relation. It's shrunk immensely, and the vegetation hasn't had time to reestablish itself. But this also allows for a zone of potential finds to exist. And this areas of recovery have resulted in a plethora of animal bones, including sheep and caribou bones that have been emerging and then subsequently recovered from these ice patches. They've also included evidence of human hunting activity. So a lot of spear points all the way up to arrows and darts having been recovered. They've allowed for research and inquiry into new hafting methods, DNA sequencing, species identification for various types of trees and that have been used for these preparations of these hunting implements. It's really been a trove of information on past hunting practices that have been recovered. Even the recovery of some snowshoes from these vast alpine landscapes have really demonstrated just how fruitful and productive these areas have been in the past. So there's already been so many recoveries that have changed the way we think about these landscapes and how they've been interacted with in the past. There's still a lot of potential recoveries that are left to be made in these areas, as we can just see with the vastness and size as compared to one of my colleagues on the toe of the alligator ice patch there, Friday Creek, sorry. So the potential for recovery continues in these areas. And this is something that we should continue to explore, but these ice patches will not be here forever. The ice will inevitably continue to melt. We can debate when, of course, but because we're here at this really pivotal moment while these objects are being recovered, we have the responsibility to document with as much detail, precision, and creativity as we can to explore these places as they exist in this moment. So for this project, I really want to look beyond the ice and beyond just the ice patches and explore more of these landscapes and how they were interacted with in the past by those that use them for generations. And one example of how all these different relationships interact with this mountainscape are with some of these curious caribou here. So humans would actually traverse the landscape with the caribou, utilizing their knowledge of the unique quality the caribou have in the warm summer months. And this is to seek out high alpine ice that has accumulated along these slopes. So seeking out these isolated patches of ice provided a cool refugia for caribou populations throughout time. The caribou congregated on the ice to escape from bugs and also from the heat of the summer months. It's an interesting behavior that they have here, and it's something that people have utilized for a long time with their knowledge of animal behavior and the landscape. But this phenomenon is not isolated to just caribou. As we can see here from this video, but sheep also take advantage of these high altitude refugia to escape the heat, and also using the daring cliffs to evade even the most limber of predators. The phenomenon of these species, both caribou and sheep, using these ice patches brought about another species to these environments, and that's, of course, human beings. So human beings traversed up to these high altitude areas to seek out these animals and to hunt them during opportune times by traversing from the valleys with their fish stock lakes up to the high altitude ice patches to seek caribou and sheep among the snow and ice. Thus, they developed and built strategic hideouts within this rocky landscape to disguise themselves amongst the tundra. Curious caribou and cautious sheep can be fooled when the wind conditions are right, and well-constructed barriers disguise the preparation for the kill. Examples of these unique structures have been documented during the ice patch surveys, but the research primarily, of course, was concentrated on the ice patch margin. So research into these structures has yet to be fully explored, and that's something that I hope to do with this documentation strategy. Therefore, to do this project as part of my dissertation, in the summer of 2020, we actually went out and planned to do an aerial survey to document all of the hunting blind structures that have been reported. So we used GPS in 2020 to document the locations, and then during the winter of 2020 to 2021, I created flight plans to then use the drones as well as a high precision RTK GPS to document and capture the hunting blind structures. I was then going to use, well, I then did use these images to create 3D maps and 3D reconstructions of all the hunting blind features that were encountered. And we camped on the Alligator Lake Mountain and some of the various other locations at this example for a week to document the site to allow for a break in weather that would allow us to actually capture all the data. And I'm going to run you through that process now, from data capture all of the way to the construction of the 3D models and my preliminary interpretations. So all of the documentation was done using drones. In this instance, a Mavic 2 professional drone. Has the Hasselblad camera, and it can withstand some pretty high wind speeds, up to 20 kilometers an hour, which is pretty useful when you're working in a remote mountainous landscape such as this, where a drone crash would be very detrimental to data collection and would break my heart. So important that it's a fairly durable and really precise little machine there. I selected aerial survey as a method to document this landscape. As it's really quick, it can cover a relatively large area. It's non-invasive and therefore repeatable, really important for archaeological documentation such as this. And this method of digital documentation is significantly cheaper than ground-based excavation or surveys. And it's really revolutionized our understanding of the landscapes in recent years. So how drone photogrammetry actually works to reconstruct the landscape is you basically have a drone, the little Mavic 2 professional here, and you want to fly a grid pattern over the area. This allows you to capture multiple oblique angles of the same object or landscape feature. That way you're able to triangulate that information with the known height above the ground surface or feature of the drone. And then you're able to calculate the distance from that object to the drone, thus determining that Z coordinate. And therefore, with the known precise GPS coordinates providing the XY horizontal features, you're able to use that algorithm to triangulate that third dimension and thus reconstruct the landscape in 3 dimensions. So that's the basic principles of how photogrammetry work. How I actually applied it in this setting to get the highest resolution I was able to achieve. So you want at least between 70 to 80% overlap on a transecting grid. So that means each photo has about 70 to 80% latitudinal and longitudinal overlap with the photo next to it. This allows for the ideal calculation in that triangulation calculation. And for the parameters of the flight, it's best if you start with calculating your desired GSD, or your ground sampling distance. So that's basically the amount of detail you want to capture on the ground. And then you want to calculate that by using this equation, basically, of your flying height to the amount of detail. It's sort of a balancing act you need to maintain. So I flew the grids using Pix4D capture to help determine an ideal ground sampling distance for each feature that I was documenting. I usually tried to maintain about an average of 1 centimeter per pixel, but then in reality, by the time it was done processing, I ended up with averages of about 2 to 3 centimeters ground surface. So to show you an example of the Pix4D capture, this is one of the flights that are planned. It's a transecting grid, so it'll fly vertically and then horizontally across this area, hoping to be captured. This is about 100 meters by 200 meters of an area, and the flight time was approximately 19 minutes to get it done. This will be vary depending on like the wind speeds that you're battling and the conditions that the drone is flying in. So you want to sort of, again, have that balance of what ground sampling distance you want to achieve and document, as well as what conditions you're working with. And one big battle that you're dealing with when documenting landscapes in this manner is, of course, the battery life. So each battery only lasts about 20 minutes. So really important to try to keep your flights under that time frame. So here's just showing all of the various transecting grids that were flown, with each of these black dots denoting a feature and the red cross hatching showing where the flights were done. We spent about a week camping at this site, but only had about 4 days with good enough weather to actually document the features. This is showing Alligator Lake and just an approximate location of where we were working to situate you a little bit better. And again, showing all of those flights that were required to document this landscape. This is an example of one of the models it's being processed. So Pix4D Capture is a free application that you can use on a phone or tablet to actually fly the grid. And then Pix4D Mapper is a technology or software you want to use to then model the 3-dimensional landscape. Pix4D Mapper ranges in price, but there's actually like a perpetual educational model that's in about the $6,000 range, which means it's a one-time cost and you can use it forever. So one benefit to drone photogrammetry is that it's able to be conducted for relatively cheap. So Pix4D Mapper includes a 3D surface output, and this allows you to create orthomosaics, which are the 2D outputs of the ground surface reconstruction using the acquired photographs, as well as a second output, which is a DSM or digital surface model. These are extremely valuable for documenting the numerous over 50 hunting blind features we found scattered at just this one site. So to document all these features in detail, map their orientation, and then begin to study their relationship to trails, it's of course really difficult to conduct when you have a limited amount of time on this landscape. So as time was valuable, we decided to fly all these grids and put it all together to determine as much information as we could. And I'll show you just one example of one of the models that were processed here, overlaid with our high resolution RTK GPS data. So here's showing where some of the grid flights were. This is a larger map of the entire area with all of the different features documented. I'll specifically be talking about this area here. You can see this is a rough showing of our digital surface model of the area. If we zoom into this area, you can see it overlaid with our RTK points. And immediately you can begin to recognize features that pop out of this digital surface model that may not be visible from the ground level, such as these trails intersecting the landscape. We can explore using this technology, the landscape in new ways and new perspectives, and potentially even identify new features from this aerial perspective that may not be as readily apparent on the ground. There's marks that have been left from animal and human use on this landscape, and it allows us to explore this in new ways. So using these models, we're able to develop a better understanding of the complex use of these landscapes over time. And we can display these models in interactive ways through virtual reality experiences, such as using virtual reality Oculus goggles to study and share these remote landscapes. So in order to understand and share the significance and value of these places, I find it's really important to get this visual comprehension to see and experience this landscape in new ways. So we can better understand using these methods how the landscape works together, how the people modified the landscape and demonstrated an immense knowledge of animal behavior to use the landscape. We can put it all together as we imagine the hunter crouched down and obscured from view of any caribou coming up the valley to go towards this ice patch here, as they're intercepted along their journey by the hunter. So we can put all of this information together with our RTK data. We can accurately map trails and hunting features together. And we can see how all of these different features fit together and gain a better understanding of this use of land, looking beyond just the ice at how the movement on this landscape has been used and changed through time. So by gaining these new perspectives, we're able to see, experience, and understand the landscape in new ways. We can see how human and animal activities and interactions have shaped and continue to shape this land. We can begin to recognize that monumental architecture comes in many different forms. We now have the evidence to recognize the authority of these monumental aspects of these mountainscapes. We can begin to see these mountains and their features from new perspectives, and a lot of value is added to this. So just showing you here the drone photogrammetry, I was able to get less than 3 centimeters in precision, and I've compared it with ground-based LiDAR, just basically demonstrating that it's cheaper, you get really high accuracies, you can conduct it relatively easily, like this is not super difficult to accomplish with modern technology. And one really exciting thing that's potentially useful for Alaska archaeology is that I've corroborated and used this technology, drone photogrammetry, on a buffalo jump that was being impacted by river erosion. And you can see here how by using cloud comparison or change detection, we can easily see where this erosion is being impacted and quantify this change. And if you want to hear more about this, stay tuned for Katelyn's talk that is coming up right away, where she's going to talk to you a lot more about change detection. So I hope you learned a little bit about how these methods can be applied to document change, either at coastal erosion sites or any sort of ice patch site that is experiencing change in these vast landscapes. The ice may be melting, but we have this opportunity to learn more about the past and dig into histories. We should, of course, be looking to the youth and the elders to learn about what's important to document and how we can share these stories to those that are willing to listen. And I realize I am right at time, so that is my acknowledgements, and email me if you have questions.
Kelsey, thank you so much. And please monitor the chat for a few minutes and see if any questions come up. I just thought that was so amazing. So thank you so much for sharing. And I would like to introduce, thank you for the segue, Katelyn O'Keefe is next. And her talk is entitled Documenting and Monitoring the Impacts of Climate Change on Heritage Using UAV Photogrammetry, a case study from, my apologies, I don't want to butcher the pronunciation.
I really want to hear how you're going to say it.
Qikiqtaruk, Yukon.
Very close.
Okay, thank you for your patience.
Thank you, everybody. Thank you for the shout out, Kelsey. And thank you for covering a lot of the UAV and photogrammetry background so that I don't have to repeat things. Always good. So my name is Katelyn O'Keefe, and I'm a master's student at the University of Calgary in Calgary, Alberta, Canada. My presentation today is an overview of my master's research at a heritage site in the northern Yukon. My research is part of an ongoing partnership between the University of Calgary and Yukon Cultural Resources. And this talk is called Documenting and Monitoring the Impacts of Climate Change on Heritage Using UAV Photogrammetry, a case study from Qikiqtaruk, Yukon. In this presentation, I will begin by briefly discussing the study location, Qikiqtaruk, including its physical location and cultural significance. Next, I will briefly outline the climate processes that are impacting heritage on the Yukon coast. This is followed by a quick overview of how UAV technology is used in heritage. And then I'll talk about the data collection, processing, and change detection methods I use, following with the results of my research. The talk will conclude on an overview of the project's outcomes and future work on Qikiqtaruk. Before I start, I just want to acknowledge that I've been privileged to work on this project in the traditional territory of the Inuvialuit. In addition, throughout the pandemic, I've been working in Treaty 7 territory, the traditional home of the Blackfoot, Tsuut'ina, Métis Region 3, and the Nakota Nations. So where exactly am I working? Qikiqtaruk, also called Herschel Island, is an island off the Yukon North Slope, approximately 60 kilometers or 37 miles east of the Alaskan border. Qikiqtaruk means big island in Inuvialuktun. It is in the traditional territory of the Inuvialuit. To the east of Qikiqtaruk is the Mackenzie River Delta, the second largest river delta in the Arctic. Simpson Point, adjacent to Pauline Cove, is the island's most culturally significant area and is the area within this presentation. Just pointing at that area here with my cursor. Pauline Cove is culturally significant because it's been occupied for hundreds of years, first by the Inuvialuit and their ancestors, the Thule, and later by Euro-American settlers. Pauline Cove became a hub for the whaling industry between 1890 and 1908. At its heyday, over 1,000 people overwintered there, including Inupiaq, Inuvialuit, and Dene, who came to work for and trade with the whalers. Following the Klondike Gold Rush and the Alaskan boundary dispute, the Canadian government assigned several members of the Northwest Mounted Police to keep order. The new detachment there became the sub-district headquarters of the Western Canadian Arctic from 1910 to 1931. These officers served to represent Canada's commercial interests, enforce Canadian presence, and enforce Canadian law. While whaling declined rapidly after 1908, the fur trade and missionary activities continued at Pauline Cove. As a result of all of these activities, there are a plethora of heritage features on Simpson Point, and the island was made a territorial park in 1987. The heritage features include the remains of numerous Inuvialuit sod houses and historic buildings. I've included these photos to illustrate some of the heritage features on Simpson Point. At top left is an excavated sod house feature, excavated by Max Friesen and crew in the 1990s. In the background is St. Patrick's Mission House, built in 1916. At top right is the community house, built by the whalers in 1893. It is the oldest wooden frame building still standing in the Yukon. The bottom right image is of the last standing ice house, also built in 1893. Lastly, the photograph at bottom left was taken in 1895 and shows the number of ships overwintering in the cove. While today there are no permanent residents, Pauline Cove serves as a staging area for researchers and seasonal park rangers. Additionally, it is a traditional hunting and harvesting area for the Inuvialuit. Along the Yukon coast, there are 5 main interconnected climate processes that impact heritage. These are coastal erosion, overland flooding, permafrost melt, sea ice loss, and sea level rise. As indicated by others in this session, all of these are really highly interconnected. Of greatest concern in the vicinity of Pauline Cove is coastal erosion and overland flooding. Various studies have measured the rate of coastal erosion in this area, and Simpson Point is a highly dynamic landform. Erosion is hastened by an elongated ice-free season, leaving the beach exposed to wave action and storm surge events. The entirety of the spit is within 1 meter of sea level, with several low-lying areas. As a result, storm events, ice push, and snowmelt contribute to overland flooding, which damages heritage features. And as a result, the heritage on Simpson Point is at great risk. These photos here, the top here is 2019, and it is a block failure. It is being undercut by the warm water, and the next day we went back and it was gone. And at bottom here is an example of the standing water in proximity to the heritage buildings. The documentation of the heritage features and of the recent change to the landscape using drone imagery is the focus of my research. Firstly, I'd like to explain a few terms. Again, I won't go into tons of detail. Kelsey did cover quite a bit of this, but I just want to mention that UAV stands for Unmanned Aerial Vehicle, but it is most frequently called a drone. Drones can be used to collect aerial imagery of heritage sites and of the landscape. Photogrammetry is the art and science of making measurements from these photographs. Photogrammetric software, such as Pix4D mentioned in Kelsey's talk, takes the images collected by a drone and looks for overlapping features, eventually registering these photos into one large image called an orthomosaic. Drone imagery has several, or even many, heritage applications, including archaeological survey, site revisits, and for site and excavation documentation. Multi-temporal imagery can also be used for change detection analysis. Change detection analysis is a collection of techniques that detect change in a scene from one data set or one time to another data set or time. Lastly, drone imagery is excellent for heritage monitoring purposes, especially for remote sites. This research uses 2 change detection techniques in tandem to detect change at Simpson Point. So I haven't gone into all the details about the data collection. If you have questions about that, I do have my email at the end and we can definitely discuss it. But for my research, I used 2 UAV data sets, so one from 2017 and one from 2019. The 2017 data set was one of several collected by Dr. Andrew Cunliffe and colleagues in July of 2017, and they collected it to measure rapid coastal erosion. They were intending to use it for vegetation studies, but when the coast began to erode really, really rapidly while they were there, they took advantage and took extra surveys. So this data set covered a larger area and was clipped to the extent of the 2019 data. The 2019 data was collected by Dr. Peter Dawson from the University of Calgary, my supervisor, Christian Thomas of Yukon Cultural Resources, and myself in July of 2019. Post-processing, orthomosaics and point clouds were produced for both of these data sets. And on the left here is the 2017, and on the right is the 2019 version. Now, this is a really large area, so 2 smaller areas on Simpson Point were selected for study. Study Area 1, which is labeled 1 on this map, was selected because it encapsulates many of the historic buildings. And Study Area 2 was selected because it includes most of the Inuvialuit sod house features, including 2 that were really close to the beach. The original orthomosaics and point clouds were clipped to the extent of these study areas. So the first change detection method I used is called cloud-to-cloud distance computation, or C2C for short. This is a technique done within Cloud Compare, an open source software. The technique compares the 2017 and 2019 point clouds using a form of nearest neighbor analysis and quantifies the distance between each point in the cloud to the closest point in the other cloud. The result is a recolored point cloud or a scalar index, which is what this is called. On the left is the recolored point cloud for study area 1, and on the right is the cloud for study area 2. I labeled areas with prominent change alphabetically, starting from A and going to S. So this quantifies the change. However, it does not yield information about the cause of the change. So that's why I used this next change detection method. So the second method used is called visual inspection analysis. For this method, the orthomosaic imagery from 2017 and 2019 was superimposed in GIS, and I overlaid a 10 by 10 meter grid. In the first round, I really looked at the areas I labeled A to S in the C2C results, inspected them, looked at what the change was caused by. Then in the second round, I went through and I looked at each 10 by 10 meters square within the grid for any change, and especially looking for change that wasn't detected or maybe was a little too subtle for the C2C to catch. At top right is an example of one of those labeled areas from the C2C and the orthomosaics beside it. And this one's really interesting because it's aerial imagery and it was really difficult. If I didn't have the C2C change map here, I wouldn't have known that the change happened. So what's happened is a pileup of sand has occurred. And also the back of that warehouse building is changed in elevation, something that's really hard to tell in just the imagery. I confirm that the elevation change did occur and was the result of conservation efforts, part of the heritage crew. And then at bottom here is another example of the orthomosaics with the grid and as the change map. Very hard to see, but in this image here, there are two spots just right in the middle here. Those are our new Vialouette sod houses. Those are the ones I said were really close to that beach. And as you can see, there is change happening all in front of them. I did crop this so that the actual water is not in the image because I knew that that would cause almost an artificial change or reflection in the point cloud. But you can see that close to these structures, there is change happening. So this was used to verify all the changes in the C2C method and also really useful for identifying what these changes were. So I can't really go over all the results in just this short talk, but here's an overview. In 2019, there was more standing water in the low-lying areas within study area 1 and 2. There was also significantly more driftwood deposition along the beaches and inland in 2019 than in 2017. Driftwood's carried from the Mackenzie Delta by sea ice, and then it gets trapped in that ice as it gets brought westward towards Qikiqtaruk. And because it's found further inland and in large numbers and large pieces, it may indicate that there was more ice push or more storm events that carried this wood inland. As previously depicted on the last slide, there's also erosion occurring on the beach in study area 2, encroaching on 2 of those sod houses. So in the image at top left here, again, it's very zoomed out, but the features I was talking about are right in this area here. And you can see this is the 2017 shoreline. It is superimposed on 2017 imagery, which is what was on ArcGIS, but 2019, it has receded. And I also am showing the 1970 shoreline based on an aerial image. And another change that was really noticeable was that vegetation in commonly used pathways is being trampled by visitors, researchers, tourists, etc. And the pathways in 2019 were larger and more in size than they were in 2017. So you can see that in the bottom left here. So this is 2017, same pathway in 2019 here. Lastly, there are several historic features that are settling or shifting. This includes the RCMP dog kennel structure, which is the bright red in the top right. You can see the bright red change just around the outskirts of the fence, something that was really difficult to catch in the ortho imagery, However, after consultation with the heritage restoration crew, it's clear they're not the ones who have been modifying this building, and it's happening naturally. Most importantly, the methods I used worked really well together. Visual inspection acted to verify and describe the change detected in the cloud comparison. And the cloud comparison also detected several elevation changes that were not visible in the aerial imagery, including the raising of a heritage building in 2018. In the C2C, the elevation change was measured to be approximately 0.5 of a meter. After consultation with members of the heritage team, I was informed that this building was lifted 0.45 meters in 2018. This confirms the accuracy of the C2C results. The outcomes of this project are the confirmation that UAV imagery can be used for change detection analysis. In addition, my research successfully repurposed found data. My research focus had to shift during the pandemic. And without the 2017 data set, this research and the change detection analysis would not have been possible. Lastly, the procedures used in this method work really well together and can be used towards the development of a heritage monitoring strategy for Qikiqtaruk. They can also be applied for heritage monitoring strategies for heritage sites in other circumpolar environments. If travel restrictions ease this summer, the intent is to excavate the 2 at-risk house features along the beach and study area 2. In addition, we will capture UAV imagery of Simpson Point in July 2022 to compare with the 2017 and 2019 data. This data set represents a unique opportunity in scientific research because the imagery would capture the impact that a global pandemic, aka the absence of human presence on the island, has had on a delicate Arctic heritage site. Lastly, my supervisor has been working to digitally capture the historic buildings on Simpson Point since 2018. There will likely be a continuation of this work. For more information on this research, the history of Pauline Cove, and on the digital preservation of the historic buildings, check out the Digital Preserve website included on this slide. Happy to put it in the chat as well. Thank you for taking the time to listen to my presentation today. And I'd like to acknowledge my supervisor, Christian Thomas, and others with Yukon Cultural Services, Dr. Andrew Cunliffe, the Aklavik Hunters and Trappers Committee, and the Qikiqtaruk Territorial Park Rangers. In addition, I'd like to thank members of my research group, including Kelsey Pennanen. This research was funded primarily by the University of Calgary, Yukon Cultural Services, and some additional funding was provided by the Royal Canadian Geographic Society. If there are any questions, I can be contacted at the email included on this slide. Thank you.
Katelyn, thank you so much. And we are scheduled for a 20-minute break. So if folks have questions, we have time. Standing. You're welcome to come off mute or put your questions in the chat if you have any. And I'll ask Katelyn and Kelsey, Leslie, Jonathan, and Sarah to kind of monitor the chat over the break and see if there are any questions that come up.
Hello, John. This is Chris Thomas from Yukon Archeology on the other side of the mountain from you, but I don't know if you caught it in Kelsey Pennanen's talk there. She showed a 2019 and a 2021 image side by side of one ice patch, one completely devoid of snow and one completely covered with cornices in the middle of summer. That's just directly, that whole zone directly north of Qikiqtaruk Park there has just been walloped with snow the last 3 years. So we often wonder, and we don't get to go to Skagway anymore because of the pandemic, but we're wondering how that looks for snowpack on your side, just visibly. Like in 24 years, we've never seen anything like it. So I wouldn't be surprised if snowpack is another cause of grief for you guys.
Yeah, thanks for bringing that up. It's been great for cross-country skiing, but it's definitely not good for discharge and our cut bank problems. I guess last year, one sort of, I guess, touchstone is last year when we went up to investigate the Friday the 13th flooding throughout the watershed, but especially at Sheep Camp where you had this huge avalanche right at the scale. So before you even take the Chilkoot Pass, there was still snow. There was just, it's an incredible amount of snowpack. And I'm relatively new to the park and was revisiting the Ice Patch Archaeology plan, and actually really excited to kind of pick up the charge. And yeah, it's kind of a non-starter now because there's so much snowpack that's not completely thawing. So really, there's nothing new to see at the moment, but who knows? Yeah, what the next few years will bring. But I'm glad you touched base, and it would be great to stay in touch. And what I meant by kind of reworking some of our research objectives that the park has established and stated in the 90s, and a lot of them are still good, but really working with Sarah Cash and our other traditional partners, I think we have a lot of work to do to look at the Qikiqtaruk past, and it becomes especially apparent when we look on the other side of the watershed into the British Columbia and Yukon. Just the resolution and I guess yeah, the information is just much more substantial than what we have along the trail and at the Tidewater. Not because it's not there, but I think because we need to look systematically.
Yeah, but yeah, no. But the good thing about the snow is it's given us a bit of a reprieve, but it's an excellent time to document snow and how it forms, because you get to see everywhere it drifts. So it's probably, even though you're not looking for artifacts, it's a great way to capture that feature of the landscape in
Totally.
detail. Anyway, that was cool. Thanks.
Oh, thank you.
Yeah, actually, where did you, you did say it, I'm sorry if I forgot, get the LiDAR data, like acquire it for those like channel reconstructions?
They've actually, Klondike Gold Rush was the first park in Alaska to get a LiDAR survey. And unfortunately, I guess it's a little dated now, but that was in 2008 that they flew this section of the valley. Actually, the park has 2 units. They also flew the White Pass section. Since you're just on the other side of the watershed, you probably know where that is, the train route. They did both of those in LiDAR. But I would love to have more. It was kind of an obstacle to show the progression of erosion in Dai, but then I'm kind of stuck with the LiDAR from that one moment. And I think it would help us quantify the amount of loss. I mean, it's pretty easy when you plot in, pretty much the size of a Carlock church, last year has fallen into the river. But to really, I think, tally how much we're losing of the NHL would be really useful. So bring your drone. I don't know. I don't know if we have too many trees in the way to really
might be
give you
able
the
to supplement if the LiDAR is out of your budgeting. You might be able to supplement with drone data. And yeah, they're coming out with some pretty cool new ones that are not too hard on the bank. The Mavic 3, I think, is coming out soon, and that will be, you'll be able to get a lot of detail, good flight times, and hopefully even reconstruct it and then have more data sets to be able to compare to and see. I don't know, might be interesting.
Yeah, totally. I picked up a mini DJI and used it to map a quarry site in Crete, Greece, where I'd been working, but then I wanted to fly it more here, but we have a lot of bald eagles around, and permitting and flying it in the park is, I was really excited to do so, but found out quickly not advisable or permittable. So that kind of grounded my little drone.
Ooh.
You know, as far as I know, I think there's a moratorium on drone flights in parks in the US right now. And I don't know the specific details around that, but yeah, it's too bad. For the time being.
Yeah, I don't think it's, I'm not too, I don't know for sure, but I don't think it's allowed in national parks or many provincial parks in Canada either. So
There is a permitting process that you could apply for a path, like a research permit, but it's especially hard to get in this zone because we have bald eagle nesting and habitat. So
yeah. I was thinking, Katelyn, our research group has this EV drone, and it actually has a maneuver called like a rollover, where if a large bird of prey is coming to attack the drone, you hit the button and it like does this cool little spin out thing to evade the predator.